Thanks for listening to The Innovation Experts, a new global podcast brought to you by Farnell, Newark, and Element 14, where you can find out about the latest innovations in the world of electronics. Hello, and welcome to our expert interview in the new global podcast from Farnell. My name is Cliff Ortmeyer, and I'm the Global Head of Technical Marketing at Farnell, and joining you from Chicago. Today we've got Dr. Philipp Weigel from Rohde & Schwarz joining us from Munich in Germany. Philipp started working for Rohde & Schwarz as a product manager in charge of entry-level oscilloscopes, but today he leads a product management team for power products, meters, sources, and audio analyzers at Rohde & Schwarz. Welcome to the podcast, Philipp.
Hi, Cliff. Thanks for having me.
So, hey, let's just start off with you telling us a little bit about yourself and your career. You know, what ultimately ended up bringing you to Rohde & Schwarz?
A good question. So I studied physics at the Technical University in Munich at the Max Planck Institute, and then did my PhD at CERN at the Atlas experiment hunting the Higgs. And after this experience, essentially, I looked around what to do, and Rohde & Schwarz was an interesting company as it allowed to explore many different other applications in test and measurement. And as a product manager, I had the chance to go into a lot of different trades, so R&D, production, service, sales, and I really like this combination of different facets in the product management of R&S.
Yeah, I got to say you're the first person I've ever spoken to that had a relation to finding the Higgs boson. So that's pretty incredible. I'm pretty flattered to be talking to you. So, you know, a lot of people have heard about Rohde & Schwarz, but can you give us a bit of an overview in terms of what kind of product lines that you guys have that they might not be so familiar with?
Sure. I think first, maybe if you're talking about Rohde & Schwarz, important to see it's a family-owned business. We were founded about 85 years by Mr. Rohde and Mr. Schwarz, and the kids and grandkids are still running the business, and actually our CEO and Christian Leicher is a direct grandkid of the founders. Nowadays we are all over the world, 12,000 people working at Rohde & Schwarz, 2.5 about a billion in revenue, and as you just said, we are in many different business fields, not just the test and measurement, all connected by this claim, safer and connected world.
Yeah, I know you guys obviously quite strong in the RF space, but you've got a broader product portfolio than that. What kind of products do you guys get into?
If you abstract from the test and measurement, so we have essentially four main pillars in R&S. So we have the test and measurement, and we can dive into this in more detail as I'm from this division. But there's three others. First, there's broadcast and media, and if you would call up your local TV station, they most likely would have a broadcast station by R&S. But we're also diversifying across the whole chain of production till delivery. The third pillar is our aerospace and defense pillar. You might have had contact with products here if you boarded a plane. Obviously, in this pandemic times, it's not so often the case. But with new body scanners, if you're at an airport, it's a security check, the body scanners are an R&S product in this space, but also the communication of like police forces and firefighters is a big chunk of R&S in this domain. And the last pillar of the R&S company is network and cybersecurity. So a lot of communication nowadays is happening, and securing this communication, like encrypting, decrypting it, so that you don't have eavesdrops on your line. This is the fourth pillar. Wow. As said, so I'm from the test and measurement division, and you said it right. Most people know us for our RF equipment, and definitely we are one of the market leaders in this wireless communication space. So any cell phone you would find in the market most likely was tested with our equipment. Obviously, we also have a lot of other RF equipment like signal generators, spectrum and signal analyzers. We're also one of the market leaders in EMC and field strength measurements. Our RF and power meters are leading in the field. But, and this is often not seen, we are also very strong in on the digital side, on the other side of the Fourier transform, like oscilloscopes and power supplies.
Man, you guys cover an amazing amount of technology. So next time I go through the airport, I'm definitely gonna, when I go through the body scanner, I'm gonna go Rohde and Schwarz under my breath there. So speaking of technologies, I mean, what do you find the most interesting in terms of technologies or markets?
Yeah, as I said, also when I joined from CERN essentially to Rohde and Schwarz, one of the things driving our times is now essentially what is also our claim at RNS, like safer and connected world. So you're seeing now the 5G rollout. So a lot of things get connected. We're speaking of the Internet of Things. Everything gets online. On the other side of this, if I look to my phone, every time it runs low on battery. So batterification and like the battery lifetime is a big topic in these days. And I really think it's thrilling to be there to make this longer lasting batteries.
Yeah, no, I get that one. That's I mean, they're basically in everything. From your standpoint, what do you think? Speaking around the test and measurement side, what presents the biggest challenges for you guys from the test equipment side?
Yeah, it's a good question. So obviously, for our engineers and for us, a challenge is always a great thing because we are all people thrilled to drive technology and see where we can get. But obviously, if we are looking into this new mobile phone standards, and if you're looking not only just to 5G but to 6G and the very high frequencies, higher bandwidths, this obviously is, from a technology point of view, a really complicated thing to get there, but it's also exciting. On the other hand, if you look into the green energy and the higher efficiency, this obviously means higher dynamic ranges and very small currents if you measure it. So if you think of a phone being in a deep sleep state, going to a transmit state, you have orders of magnitude and current change there. So this is also a real challenge to get this better and better.
Yeah, I think, in the old days, I used to work in a little bit in RF, and I know it was a challenge just working in the low megahertz region, in terms of skin effect and having to make sure that, you had impedance matching and everything. But now with, like you said, 5G and even 6G, the frequencies we're talking about are unbelievable. Now everybody's got to learn about waveguides and, and the low power, like you said, the quiescent power and the quiescent currents, the precision that has to be, done from the test side, just the measurement setup has to be almost perfect, I'm guessing going forward.
Yes, and this is really a challenge, and we are also working together with not only like normal industry, but also research institutes to get like the newest technologies there in auto products, and this is also really exciting.
So from a product standpoint, for Rohde and Schwarz, where do you see the most growth in terms of the product families? Are they all growing the same, or do you see certain areas really taking off?
Obviously, in each company, each different areas have different dynamics. And if you now look at this present time, and this is also what I just elaborated on, 5G is rolling out. So obviously, in the 5G sector, we have a very dynamic market at the moment. But also this topic about power consumption. This is getting real to the point. A lot of companies bringing batteries to a lot of devices where they haven't had batteries 5 years ago. And so this is a very dynamic field as well.
And I'm guessing, what kind of things do you have to do in terms of testing batteries? I mean, with the battery development, what are some of the key types of equipment that you need if you're going to be either producing batteries or even just using batteries in your applications?
So if you look into batteries and the whole ecosystem of batteries, obviously you start in finding the right materials, over producing a battery, over optimizing the usage of a battery in a device, in the end to recycling. And depending where you are, you have different applications. But if we are sticking for a second, let's say with a phone or with a smartwatch or some other device, one key application there obviously is getting the power consumption as low as possible, because every battery has a certain capacity, and the longer it lasts, the less power you use, the longer that battery lasts. So what have you to do? Typically what you do is you implement different states into your device. So you have some transmit state, you have some idle states, and you have some sleep states or even deep sleep states. And this is a real challenge in R&D if you are tuning this, because obviously you want the device to be transmitting and reactive to your customer whenever he wants it. And on the other hand, you want to go to this deep sleep state as fast as possible so that the battery lasts as long as possible. And to analyze this, you need power analyzer or power supplies or an SMU, which allows you to really have measurement at high precision and accuracy at very low currents, and then within a second at high currents, so you can really understand how this power consumption is. And then obviously you want also to correlate this to other features. So for example, you're looking at a YouTube video and you want to see, oh, now it started this feed and how does it work? So you want to have protocol analyzers, or you're just looking into it with a scope to certain things happening on your circuitry and correlate this back to your power consumption.
You know, you actually mentioned one device that it's always been in the back of my mind, and I never had the chance to use it when I was on the bench. But an SMU, it's one of those devices that I always thought, I know I can characterize a diode with it, but it always seemed to be a very high tech and really, a machine that's really only used for specific applications. Would you mind just kind of giving me an overview in terms of what an SMU really is and the applications that it's best used for?
Sure. So what's an SMU? So SMU stands for Source Measure Unit, and this name already gives part of it away. It's a test and measurement device which can source and measure at the same time. So typically, what people understand under SMU is essentially a high-end power supply, which can very precisely and accurately power. But then in the same box, you have also the functionality of a DMM, so you can measure what you're supplying or how much current, how much voltage, and often then you also have further analysis functionality which can derive you like power or other quantities from this measurement. And this all tied up in one box, so you can also not only replace equipment on your box, but you also correlate these measurements within the box so you have a defined state. And then there's another important thing about this power supply, because it's typically not just a standard power supply which gives you like 12 volts and 5 amps or whatever, but it's typically a power supply which is a so-called 4-quadrant power supply. So what does this mean? A standard power supply gives you positive voltages and positive currents. So you put it at 5 volts and it gives you 3 amps and that's it. Then there are so-called 2-quadrant power supplies which incorporate a load as well. So these can give you a positive voltage and can deliver you current, but can also sink currents. So for example, if you're trying to discharge a battery or analyze anything, these can act as a power supply and a load. In contrast, when in an SMU, this 4-quadrant operation, these can supply you positive voltages, negative voltages, positive currents, and negative currents. So, and you just mentioned already one example. So if you're looking into an IV curve of a diode or something, obviously you want to go from negative voltages and currents, crossing the zero, going up to positive voltages and currents for this IV curve. And that's also where you often find SMUs in semiconductor environments. But as I said before, it's also a very high precision power supply, and this enables other applications like looking into power consumption of a phone.
Yeah, no, I think actually one of the things that you mentioned, it can act as an electronic load. So, I mean, if you think about it, you got a power supply, a multimeter, a source unit, basically a power supply, and as an electronic load. That does seem to be quite a number of devices all in one. I mean, can this device realistically replace 4 to 5 pieces of equipment on your bench? I mean, is it realistic to look at a piece like that?
Obviously, it depends on your application, but yes, in many applications, it can replace like loads, DMM, data logger, power supply on your bench. And I think the key point is not only it can replace these, but typically you use it in a more advanced environment, and then you also care that all your measurements are correlated. And if you have you have any circuitry, you power it with 5 volts, and then you have the current flowing and so on. And on a second instrument, like a DMM, you are measuring this. And afterwards, you try to correlate this somehow. So you try to understand, okay, now in my DC-DC converter, I switched the input from 5 to 8 volts. And what happened on the output, and so on and so forth. Correlating this sometimes get involved if you have a lot of different measurements. And if you're using something like an SMU, you're saved from this hassle because everything is contained in this one box and it works out of the box.
Got it. So right now, obviously, other than from the semiconductor standpoint, testing, what are the applications that SMUs are being used in now that they may not have been used in, 5, 10, years ago? What are the upcoming applications where it really does make sense to use an SMU?
Sure. So if you're looking at SMUs, you'll typically find them in, let's say, 3 main areas. As you just said, semiconductor is obviously the most natural one and the historic one. But there's 2 other big ones. We call them precision electronics, and the other one is research and education. So what is this? Within precision electronics, you're looking into a lot of high-end electronics measurement, like the example of the battery consumption of a phone we just had. In research and education, you have a lot of different applications, like if you're looking to quantum technologies or just material research, and you want to understand very small currents at very high accuracy, this is where you would also use an SMU.
Okay. So, when you talk about like battery testing for, mobile applications, I'd say probably 50 to 75% of the products out there are going to be using, batteries for offline usage. Does an SMU, how does an SMU actually help you utilize or be able to implement a battery in your application?
So if you're looking into an application where you have a battery, so there's different things. Obviously, there's the story we just had where you have a device living in different states and you want to optimize different states. But another thing which you can do with many SMUs, and obviously also our SMUs, is that they can also simulate you different battery types for you. So think of you're having a new design and you want to decide, is nickel cadmium the right thing, or do I need that and that thing, or how would it behave if we are on a skiing and it's very cold outside. What you can do in many SMUs is load a battery model, and the SMU will then simulate you the voltage, the impedance of the battery, over the different state of charge states of the battery. So you can sit in your clean room, or actually just your lab, without leaving your house. This sounds a bit weird in pandemic times, but and in normal times this was an advantage, that you could do it in your office, simulating the battery, and just understand how is my device working. If the battery is like 90% empty, is the device still on, or is it shutting down in an undefined state? So this is one thing you could analyze with a battery analysis option on a typical SMU. But also, if you look deeper into batteries, obviously a lot of batteries nowadays are like lithium-ion batteries. But if you look to your periodic system of elements, you could use a lot of different elements. And if you want to analyze how is this anode material working together with this cathode, or how is this chemical reacting with that chemical, this is also where you typically have to measure very small currents over the applied voltages. this topic is like a cyclic voltammetry. So, and where you can analyze this with an SMU, because you need 4 quadrants. You have to have positive and negative voltages, and then also measure the current flow there. This is also a very exciting topic.
That's actually a really good point in terms of, being able to, not only act as a load, but actually act as a source of, different battery types. I think that's huge in terms of the types of applications that it can be used in. Are there any other types of applications that it makes sense to really use an SMU in? Like we were talking about diodes before, but I know I've been reading some things, and actually some things from you guys, around LEDs, because obviously the world's now getting powered by LEDs. And how can an SMU help out in LED applications?
That's also an interesting topic, because if you look around, energy efficiency is a big topic nowadays, and right so. But how do you get to efficient lighting, for example? And there LEDs is one of the things employed, and this also gives a lot of cool new design things. So there's a lot of LED R&D around. And what's the challenge when you're looking into our LEDs? So LEDs are in the end light-emitting diodes. So you have, on the one hand, you typically care for the IV curve. So you need the 4 quadrants, where you need an SMU already. The other thing is you typically care at which point how much light is emitted, and you probably also care at which point your LED stops emitting the light. So you want to correlate with some other measurement. So you put like a photodiode or something to measure the light emittance of the diode. And an SMU typically has also these communication or digital I/O interfaces to correlate measurements with other things. And then last but not least, LEDs are also diodes essentially, which don't like current overshoots. And if you would use like a normal power supply for this, a normal power supply uses the voltage and regulates on the voltage. So if you set it to 5 volts, you switch it on, it goes to 5 volts and tries not to overshoot in the voltage, but it does not pay too much attention to what happens in the current. While many SMUs allow you to set a so-called current priority mode, where the power supply or the SMU will regulate on the current. And this is really key if you're looking into LEDs, because you just don't want to fry your LED with a current overshoot.
Yeah, no, completely get it. I mean, that's those are 2 huge applications I think are broadly applicable. And I definitely see, the SMUs moving out of the, let's call it the strictly, high-end semiconductor R&D space into the modern world. I definitely see these types of pieces of equipment becoming more and more prevalent on benches, and obviously we see quite a rise in those as well. You guys actually just released your own SMU, is that correct? Recently?
Yes, we launched our first own SMU. So we had some from ADCMT as third party, but our first SMU from R&S R&D about 1 month ago now.
And how was yours positioned in the market? Where do you see it fitting in?
So obviously we are very strong in the market with wireless customers, so like mobile phone companies and all these ecosystem, and therefore also the IoT companies. And this is also, we did a lot of like voice of customer, or spoke to these customers. Where are your issues? What is the challenge you have? And this is also where we defined our first SMU. It's let's say not the broadband SMU, like a Swiss Army knife. It's very versatile around all these topics of power consumption, all these topics of battery optimization.
So what are some of the key features of your new SMU? I think it's the NGU SMU, is that right?
Yes, it's the NGU family. And the NGU family comprises 2 models, the NGU 201 and the 401. So in the very strict sense, the NGU 401 is the real SMU, which has the 4 quadrants, while the NGU 201 is a high-end power supply, or but it has just 2 quadrants. Both feature a linear design and can reach up to 8 amps and 20 volts. So which is also interesting if you're thinking of fast charging your phone. So typically, if you look at like USB power delivery and other standards, you have fixed voltages. And if you want to fast charge your phone, you need higher currents. So this is something where the NGU is really outstanding. It's going down to 1 microvolt or 100 picoamps of readback resolution. So it can measure really small currents and voltages. I think it goes up to 8 amps, so it's a high dynamic range with 4, respectively 6 ranges of measurement. And last but not least, it has a real new and crisp user interface, since it has a very large touch screen, which allows us to do things which would not be possible like with normal 7-segment screens.
I know you said it's not a Swiss Army knife, but according to those specs, I'd say that's pretty close to one. I mean, with that kind of range of power and that kind of precision, that's a pretty amazing device. I might have to see if I can get one to throw on my bench here at home just to play with, keep it around. That's actually really, really interesting. I learned a ton today, and I appreciate your time, especially around the SMU part. I think that's going to be really valuable to a lot of our listeners. At the end of each podcast, I got to ask some questions just to get to know you a little bit better. So, call it the quick fire round. You ready for a few quick fire questions?
Sure.
All right. So tell me, being in the T&M space, what's the craziest application that you've seen one of your products used in?
That's a good question. Let me think. So I think the most craziest thing, it's not really a question if it really was an application or they were doing it for fun. I have to search out the YouTube video of this thing. I think it was a YouTube video. There was one guy who used one of our power supplies essentially to play music for the different songs, and he got actually pretty well into it. So if you look into our power supplies, they typically also have an ARP functionality inside, so you can also sometimes replace an ARP, and he was exploiting this ARP to create like a stereo equipment out of it.
It's your poor man's audiophile, or I guess actually the price of the equipment. Sometimes that could be the price of an audiophile piece of equipment. So that's pretty interesting. How about you? Any projects that you're working on currently? Either from the electronic side or anything that you're building?
I destroyed my old smartphone 2 months ago while so the display cracked, and now with my 2 boys, I have like a 2 and a 5-year-old boy. We are building a gaming console out of it. So we cracked it open. We're now powering it with an old PC power supply for the 5 volts of the battery, or the 3.7 actually of the battery, and using the HDMI out, which is on the USB Type-C. And finally, it should be like a small gaming console for us in this pandemic lockdown times.
I'm really kind of jealous because all of my bench time at home seems to be replacing my daughter's iPhone screens. That's the amount of enjoyment that I get out of things. So last question, and this one's a personal one, being a Marvel fan. Who's your favorite superhero and why?
You're a Marvel fan, so I should probably pick somebody from DC.
No. If you want to go DC, that's fine with me.
No, but actually, let me think. I'll go somewhere completely different. I like Darkwing Duck, I think. I'm not sure if he's famous in the US, but actually, as a kid, I really liked Donald Duck, and Darkwing Duck has it's like amazingly translated, and it's just funny. So I will go for Darkwing Duck just to tease you.
I think I've actually seen that one before. So yep, that's a cool one. That's respectable. Well, hey, thanks for taking the time today. This has been awesome. If our listeners want to, get in touch with you, what's the best way to reach you?
So there's certain ways, obviously. You can always contact us via RNS, the Twitter feeds we have, or just drop me an email.
Okay, sounds great. And anything else you want to talk about or bring up before we go?
I hope you all stay healthy in these times, and hopefully soon we can meet each other in person again.
Yeah, and actually get outside and do some battery testing instead of keeping everything in the lab.
Yeah.
Oh, this has been awesome. So anyhow, thanks, Philip, for joining us today and sharing your insights. To our listeners, we hope that you enjoyed today's episode, and I'd very much like you to encourage you to check out Philip Weigel and Rodian Schwartz online to find out more about their specialist products and services. And with that, thanks for listening.
Thanks for having me.
We'd like to hear what you have to say about how test and measurement equipment supports innovation in your industry, so please get in touch with us at technology@farnell.com. If you enjoyed the podcast, don't forget to subscribe on Spotify, Apple Music, or wherever you get your podcasts. All right, I'll see you all for another interview on the Innovation Experts very soon. Until then, thanks for listening.